Hey everyone, welcome back. So you've probably heard the term AI agent thrown around a lot lately. And maybe you've also started hearing things like multi-agent systems. If that sounds like sci-fi jargon, don't worry. Today we're going to break it down in a way that actually makes sense. By the end of this video, you'll understand 5 different ways AI agents can work together and why picking the right one actually matters. Let's get into it. First, a quick mental model. Think of an AI agent as a smart employee. It receives a task, figures out how to handle it, uses whatever tools it has, and produces a result. Now, what happens when one employee isn't enough? You bring in a team. A multi-agent system is exactly that, multiple AI agents working together to get something done. And just like with real teams, how they coordinate makes a huge difference. That's what this video is about. Not whether to use a team, but how to organize one. Before we dive in, let's quickly define what an agent actually is. An AI agent receives a task, uses tools and reasoning to work on it, things like searching the web, reading documents, writing code, calling APIs, and then produces a result. The key thing, agents can act autonomously. They don't just answer one question and stop. They keep going until the job is done. Multi-agent equals multiple of these, coordinating together. Let's start with the simplest pattern. Pattern 1, Generator-Verifier. The analogy here is simple. Write a draft, then have someone check it. If it fails, rewrite with the feedback. Here's how it works. A generator receives a task and produces an initial output, a draft, a piece of code, an email response. Then a verifier checks it against specific criteria. Is it accurate? Does it follow the right format? Does it actually answer the question? If it passes, great. If not, the feedback goes back to the generator, and it tries again. This loop continues until the verifier accepts the output, or you hit a maximum number of retries. This works really well when you care about quality, and when you can clearly define what good looks like. Customer support responses, fact-checking, compliance documents. These are great fits. The catch? The verifier is only as good as its checklist. If you just tell it to check if it's good with no specifics, it'll wave everything through. Garbage in, garbage out. You need to define exactly what the verifier is looking for. Accuracy against a knowledge base. Tone against brand guidelines. Whether every issue in the ticket was addressed. If there are no criteria, the verifier just rubber stamps whatever the generator produces. That's the #1 failure mode with this pattern. Pattern 2, Orchestrator-Subagent. Think of it like a project manager and a team of specialists. The orchestrator, the PM, receives the big task, breaks it down, and hands pieces off to subagents. Here's how it works. A lead agent, the orchestrator, receives the task and determines how to approach it. It may handle some parts directly while dispatching others to subagents. Each subagent focuses on their specific job and reports back. The orchestrator pulls everything together into a final output. A code review is a perfect example. You need someone to check security, someone to check test coverage, someone to check code style. The orchestrator assigns each job, waits for the reports, and writes the final summary. Clean, organized, efficient. The limitation? The orchestrator can become a bottleneck. When a subagent discovers something relevant to another subagent's work, that information has to travel back through the orchestrator. If the security subagent finds an authentication flaw that affects what the architecture subagent should be doing, the orchestrator has to catch that, understand it, and reroute it. After several such handoffs, critical details often get lost or summarized away. The bigger the system, the more this matters. Pattern 3, Agent teams. When work decomposes into large, parallel subtasks that each take a long time, Orchestrator-Subagent can feel limiting. That's where agent teams comes in. Here's the key difference from the previous pattern. In Orchestrator-Subagent, subagents do one bounded task and then stop. In agent teams, the workers are persistent. They stay alive across many assignments, building up context and domain familiarity over time. Think about migrating a massive codebase to a new framework. You've got 10 services. Instead of one agent handling everything sequentially, you assign a dedicated agent to each service. Each one gets to know its service deeply, the dependencies, the quirks, the test setup, and works through the migration autonomously. That accumulated context improves performance in ways one-shot dispatch can't replicate. The trade-off? These agents work independently, so they don't automatically know what each other is doing. If 2 agents touch the same file or make conflicting changes to shared code, neither is aware of the other. You need careful task partitioning up front to avoid collisions. The pattern requires clean domain boundaries. Once those are in place, it scales really well. Pattern 4. Message bus. Think of a busy newsroom. Alerts come in from all over the place. Different editors handle different types of stories. No one person manages everything. Instead, there's a routing system that sends the right alert to the right person. In the message bus pattern, agents don't talk directly to each other. Instead, they publish and subscribe to a shared communication channel, the bus. An alert arrives, gets classified, and is routed to whichever agent is best equipped to handle it. What makes this powerful is flexibility. You can add new agents, new specialists, without rewiring the whole system. The bus just learns to send new types of messages to new subscribers. This is ideal for event-driven systems where you can't predict exactly what's coming. The downside? When something goes wrong, it's hard to trace. An alert disappeared somewhere in the pipeline. But where? Did the router drop it? Did it go to the wrong agent? Did the agent receive it but fail silently? With a sequential orchestrator, you can follow the decision trail step by step. With a message bus, you need careful logging and correlation to reconstruct what happened. Good observability becomes absolutely essential. Pattern 5. Shared state. Every pattern we've looked at so far has some kind of central coordinator, someone managing the flow. Shared state removes that entirely. Imagine a shared whiteboard. Any agent can read it, any agent can write on it. There's no one in charge. Everyone just works, checks what others have written, and adds their own findings. This is great for research tasks where agents need to build on each other's discoveries. Say you're doing a deep analysis of some topic. One agent reads academic papers, another looks at industry reports, another monitors news. When the academic agent finds a key researcher, the industry agent can see that immediately and adjust its investigation accordingly. No coordinator needed, no bottleneck, and no single point of failure either. If any one agent stops, the others keep going. The challenge is that without someone in charge, things can go sideways. Agents might do duplicate work, or worse, they might start reacting to each other endlessly, going back and forth without actually converging on an answer. You need clear rules about when to stop. A time limit, a convergence threshold, like no new findings for N cycles, or a dedicated referee agent whose job is to say, okay, we have enough. Systems that treat termination as an afterthought tend to cycle indefinitely. So how do you choose between them? Here's a useful comparison. Orchestrator-Subagent versus agent teams. Both involve a coordinator dispatching work to other agents. The question is, how long do workers need to maintain their context? Choose Orchestrator-Subagent when subtasks are short, focused, and produce clear outputs. Choose agent teams when subtasks benefit from sustained, multi-step work, where accumulated context actually improves performance. The other comparisons follow a similar logic. Is the workflow predictable or event-driven? Do agents need to share findings in real time or just at the end? Here's the full cheat sheet. Generator-Verifier, quality critical output with explicit evaluation criteria. Orchestrator-Subagent, clear task decomposition, bounded subtasks. Agent teams, parallel workload, independent long-running subtasks. Message bus, event-driven pipeline, growing agent ecosystem. Shared state, collaborative research, agents share discoveries. And if you need no single point of failure, shared state is the only pattern that fully delivers that. And that's it. 5 patterns for getting AI agents to actually work together well. The core takeaway: don't pick a pattern because it sounds sophisticated. Pick the one that fits the actual shape of your problem. For most use cases, start with Orchestrator-Subagent. It handles the widest variety of problems, with the least coordination overhead. Then watch where it struggles, and evolve from there. No one picks the perfect architecture on the first try, and that's completely fine. That's it for today. See you in the next one.